In case 3, we're going to deal with irreducible quadratic factors. Now, hopefully this word sounds semi-familiar to you. We did talk about irreducible quadratic factors all the way back in chapter 2. Yes, it was chapter 2. Basically, an irreducible quadratic factor is something that only factors as imaginary. So if you did quadratic formula on it, you would get imaginary numbers. If you tried to factor it, it would only factor as imaginary numbers. So something like this, x squared plus 1. If that was x squared minus 1, I could do difference of squares and do x minus 1, x plus 1. Because it's x squared plus 1, that only factors as imaginary. The fastest way you can tell if it is or not, if it factors all the way or doesn't, is to do quadratic formula on it. If you do quadratic formula and you get a negative in your square root, that means it's imaginary. Then you know it doesn't factor anymore from there. Now let's talk about how to handle these irreducible quadratics in our example. So this one, we're going to start with our first factor, the x minus 2 over here. That just gets its own a, just like we've been doing everything so far. Now, here's our irreducible quadratic, x squared plus 1. That does not factor anymore. It only factors as imaginary. Here's what we're going to do. Instead of just putting a b on top, we're going to go down 1 degree from the denominator. So this is the degree of the denominator is 2. The biggest exponent is 2x squared. So up here we're going to do bx to the first. We went down 1 degree, and then we fill in the rest, plus c. So if you had like x cubed plus 1, something like that, you would have bx squared plus cx plus d. I went down 1 degree and then filled in the rest going down from there. And that's how we handle our irreducible quadratics. The numerator of them just looks different, as you can see up here in the instructions. But from here, all the steps are the same. Once you have it split up, everything's the same. Multiply by the denominator, see what cancels, rewrite it, simplify and organize, factor, all that good stuff. And then you'll get a system of equations that you'll solve for A, B, and C using any method of your choosing. Now, because you've all done this several times at this point, I'm going to have you pause the video and try to solve this out from here. I will warn you that this is kind of the ugliest system that we've dealt with yet this lesson. Once again, you can use any method of your choosing to solve this system, whatever you want. You just need to solve for A, B, and C. So pause the video, try this part out on your own, and then come back to check your work. Let's check your work. So I multiplied by my denominator, FOILed everything out. Don't forget this numerator is bx plus c times x minus 2. So bx plus c times x minus 2, which you FOILed out to get this. Then I organize my x squareds, my x's, and my no x's together. So 5 goes to a plus b, negative 5, negative 2b plus c, and 5 to a minus 2c. So here's my system. Now, once again, you can solve this system using any method of your choice. I chose to get it into row echelon form, so I wrote my augmented matrix, and then I got my bottom half zeros in place. And then I divided what I needed to get ones on the diagonal. So now this is row echelon form. And that gives me this. So then I already have C solved for. I can plug that into the middle equation to solve for B. And plug B into the top equation to solve for A. And then once I have my system solved, I just plug this back in for A, this back in for B, and this back in for C. And there we go. Once again, I think that's our hardest system of equations to actually solve today. But you can use any method of your choice to solve it. You don't have to use the method I used. But whatever method you pick, you should end up with the same 3 answers. Let's try one more case where we've got irreducible quadratics, and then we'll move on to the last case for the day. So this one, notice our denominator is not factored, so step one, I do need to factor this denominator. They have an x in common, so I can factor that out. Then you'd notice very quickly, this is actually not factorable. You can use quadratic formula to show that, or just try to factor it in your head. It's not going to work. So that means this is an irreducible quadratic, which means that first factor gets an A, and this irreducible quadratic factor goes down 1 degree. So bx to the first plus c finished out. So there we go. We have it factored. I split up the fractions for you. Once again, I'm going to have you pause the video and try to solve this from here. I will tell you this does turn out to be a much easier system than the last one. So pause the video, try all your 7 steps from here, and get your answer. Let's check your work. So I multiplied out, wrote out what's left, simplified and organized. So I brought my x squareds together, my x's together, my no x's. I had to write my 0x squared plus 0x in front again to write out my system. I already have that a equals 3, so I plugged that into the second equation to solve for c, and I plugged a equals 3 into the top equation to solve for b, and then just filled in a, b, and c in my answers to get that. So that is all that we're going to do with our irreducible quadratic factors. In the next video, we're going to talk about our last case of the day, which is combining case 2 and 3. So we're going to have irreducible quadratic factors that repeat, that are squared, and talk about what to do with that. I'll see you for that last video of today's lesson.